Hello everybody. Oh, let's turn off the overhead light. It's making some glare. We might use it. Damon here. Crazy Logics. Crazy Logics 007 on YouTube. Got a JL Audio. It's a A1800 Class D monoblock. It's kind of roughed up here. It's lived a hard life, but the owner really likes it. One smell, and you can tell that something's not right here. You can smell the odor of burnt electronics coming out of this one. So we're gonna skip doing all the stuff. I've already checked all the things, made sure this worked, the switches, and looked at some other stuff, and flipped the back off, took the back off, and let's see if we add the overhead light, if that helps. It's going to give us a little glare. Here we go. Well, I think the overhead light's hurting us on that. Maybe not. Let's see if adding a, let's see in there. There's some burnt up resistors. I don't know if you can see on the board there. Stuff got hot. Same thing on this side. We had some components rattling around when I first opened this up, and you can see that's missing a couple of those transistors. Now, push those transistors down to help get them out of the way and to read them. We can get some of the parts out here. As I took some of those clips off over here, you can see they're just fratzed bad. And these were the little parts just floating around in there, just melted them right out of the circuit board. And they were rattling around in there. So she's definitely got some damage. This is a dual power supply. So we got power supply FETs over here, power supply FETs over here. Looks like diodes. I don't know if that's a diode. Haven't pulled that off. This is the output FETs over here. Don't have anything down through here. There is evidence of the carbonation being all the way down through here on the heat sink anyway. I don't know if that was from just stuff exploding, but everybody always wants to know how to take those clips off. This is just an Allen wrench, just like a regular Allen wrench. This will work. Well, this one won't. What you're looking for is find one that fits in the slot. Mine is a tight fit. You're wanting one that fits in the slot. And I cut it off short because a lot of times you get into places where you got capacitors or other stuff that doesn't let you get a full length Allen wrench in there very good and leverage it out. So I've cut it off short. I did it to this one because it had no markings on what its size was, so I knew it was a generic that I'd got somewhere and wasn't all that important. But you just stick it in the hole. Boy, it's tight on these. And lever it up, and you can see the clip just fits in a slot, and when it's pushed down in there, it spring tensions and holds those transistor or the FETs into or onto the heatsink. And there's some thermal insulators there. See, that's all of them. We just got this one left. And that looks like a temperature sensor. I use Ziploc baggies. Throw all the screws, clips for an amplifier in. If I have to order parts, you know, I'll set that baggie in there with that so that it doesn't get lost. Oh. So we've got all the clips off. We're going to need to get this circuit board out. So one thing we need to do is get a small pair of pliers, and we're going to gently grab all the transistors. Now, besides the obvious damaged ones, and there's obviously blown damaged ones here on this side, I did put my meter on these output FETs, and they didn't show any shorts. So we're gonna hope that they're okay. But we're just popping these free and bending them out just enough to allow us to slide this board out. Sometimes you have to be real careful with a razor knife that you're not going to scar up an insulator that's back there, but sometimes it just flicks underneath them and allows you to bend them so easy if they're slightly loose. Like I said, you don't want a razor blade or cut up the insulator. Sometimes it doesn't want to get behind there. You gotta get a little helping hand. I'm gonna go ahead and turn this around so I can see them as I do them. If I'm working on an amp, not recording, it's a whole lot easier. I can stick my head in front of where the camera is and all that stuff, and not have to worry about camera angles or trying to excuse me, make sure I'm not blocking a shot. And let's see here, we need to take these out. I've already taken most of the end screws out. Got the little ones that hold the end covers on here. Just got that one off. And I'm going to go ahead and take all these off because we need to do some inspecting of stuff. This amp, like I said, is taken a little bit of abuse over the years. It's definitely used. There's a broke off. Oh, you can't see it. So the speaker stuff is down here. You can't see it, but there's a broke off bolt right there, so we'll see if we can get that out of there. If not, with the pair of pliers, then we'll get the channel locks. So somebody may have been in this before, because it's got at least one broken bolt and it was missing another, so somebody may have peeked in it anyways, trying to determine what was wrong with it. I don't know why they would have been taking the end caps off after you took that off and seen all the fried stuff there, but we got a broken bolt, baggie, and then we need to look for screws in the center here. Looks like we have 1, 2, 3, maybe 4 here, 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 and here. And that's good. You want bolts in the center that keep the middle of the board from flexing due to vibration. Several amp manufacturers made bigger amps like this and learned the hard way that, oh yeah, those amps will bounce in the middle of that big old board if they're not supported. And some of the cheaper brands, they flexed and broke off all the legs on the FETs. These are monster long. Holy canoodles. So you see all this. Well, you can't see crap while I'm doing this. Let me get this done. So anyway, there's a whole bunch of soot and carbon on the board and around the heat sink and everything when these FETs blew, and it's not as bad as it would always look. There's some capacitors that have melted, and that's because looks like the FET got so hot and flared up around them that it screwed them up, so we'll probably change those. These big resistors are probably fine, but all these drivers, they've already got little indications that they're popped, and then all the drive resistors going to the FETs look like they popped. So this power supply went in a big way, and whoever had this probably had it too high a fuse protecting it to let it fry this fast. But when a power supply goes, and if it, I don't know what this A1800 recommends for a fuse, but if it was a big one, it'd let enough current go by to fry a whole bunch of all of this, which is one of the bad parts about big amps with big fuses, is when they do go, especially on the power supply, they go spectacularly. And there we go, just slides right out of there. Now we got to look, because I did not, I don't see any LEDs for the front badge or anything. And there wasn't. And so now maybe you can see all the soot and everything that it's left here. That looks rough. Same thing on the other side. There's a bunch of blackening. I don't know what that's from, if that was just residual soot where somebody touched it. I don't know. It's a heck of a heat sink, good and solid. JL makes quality stuff. Whew, get that big heavy sucker out of the way. Get our board back up here. Now we want, because we haven't done it yet, is to flip it over. Whoa, look at this leg and this one over here. See them sticking up? They have actually completely broken off of the FET, and that had melted that solder and it slid through. So look at the back side of the board. It all looks to be in good shape. From the back side, you couldn't tell that it would be damaged necessarily, so that's good. What we were going to look for also here, besides for damage, is to inspect these FET legs and see if they have burrs. And they do not appear to have burrs. So JL had there for a while was pretty bad about the burrs, not because they have a bad manufacturing process. It's because the holes in their boards were so tight that it was just good for a brand new FET to fit in, and their cutting process, which everybody's cutting process can eventually put a burr on there, it just made it to where that little burr was there, and when you tried to take them out, because their holes were tighter than most, it could rip the vias out and stuff. So we've got a whole bunch of these that are just fried beyond all belief. And so when you have them that are, I mean, the legs are falling out of these things, that are just super fried and blowed up, I mean, just snip these things out of here. This leg is falling off. That leg fell off. Now, any you think might have survived are not going to be good for any amplifier. But remember how I talk about, sometimes I save a couple that survive when these things happen. for initial test firing. That one was just toast. And these FETs are just falling apart. That one's blowed up. So, just for giggles, let's try and salvage the ones that don't look like they're baked. We'll then test them, see what's going on. These two are the diodes. We'll check those and stuff. We have got FET parts just falling everywhere. I mean, it's a graveyard of just horrendousness when it's got chunks out of it. I don't know if I can get that to zoom in. It's bad. So I've got my big soldering iron fired up here, and we will flip this sucker over. And grab my stick to give me a little more elevation for pulling these out, except the camera. There we go. Let's see here. I think it's got tricked into autofocus. Let me see my camera settings here. Let's go to the. Let's get it to focus here. And then, there, turn autofocus off. I think that'll get it where we now do it. It tries to compensate so much that we lose out, and it ends up making terrible video. I'm just using little Logitech webcams. I'm just going to add some leaded solder to all these, even the ones that just are legs, because we want everything to fall out real easy and to clean up. And that lead-free solder has a higher melting point, is more brittle, is not as ductile or malleable as leaded solder, and so all we're doing is making it easier to get everything cleaned out, to get all the holes sucked out. And do a better job. I have found in repairing this and other electronics that if you take your time to go on ahead and try to get everything cleaned back up and do perfect, you'll find sometimes other faults or other tore up stuff. Now while we're at it, oh, hang on. I know something I have not done that I know of. Maybe I have. Yes, I have. So I went through, took a little diagram. This just kind of represents where the junk is and where all those caps are on the other side. Let's flip this real quick. That would be this way, just so this will make sense. So I kind of got transformer. I know all these FETs are the same because I looked at what numbers were surviving, and they all appeared the same. They all had the same looking drive transistor, so that's pretty simple. But I did write down the part numbers of where they go and what their orientation were, where it was. Here, and I figured it out and I wrote it all down so that whenever I go to stuff the new components in, I won't have to take the time to figure out what went where. You can figure that out because these are those emitter follower pairs that I told you about. If you watch the that Aurora amp that I had some trouble with on the power supply because it was actually a style I hadn't quite seen. This is what I'm more familiar with. This is that emitter follower pair. So this pair is going to be driving half these FETs, and this pair is going to be driving the other. Same would be over here, and somewhere in here there'll be a chip. I don't know if it's that one. I'd have to look at them. Something providing that drive signal, and it's going to provide it into those transistors, which then run these FETs. And so you got one. You actually got two banks here. One bank, and that's running this transformer over here. This bank, and this other transformer. So it's a dual power supply to either give it the current that it needs or the voltage that it needs. To do whatever it does. Now, one interesting thing about JL, I know on their Slash series, at least on the 500 and the 1000, it's, and I think all of them, but I don't want to say that for 100% certainty. I'm not an expert by any stretch of the imagination. I do this as a hobby. They are regulated power supplies. And so they don't form that square wave just like you think they would. They'll form a neat little interesting pattern on your oscilloscope. We're dropping out nice. Let's see about grabbing these legs individual. Because it's regulated, so if you have, once it kind of builds up its juice, it goes into less duty cycle. So it looks really interesting on a scope, but there's ways to trick it into going to a 100% duty cycle, which will then make it look like a normal generated pulse width modulation signal, because that's all it is. It's just a regulated one. So anyway, I kind of wanted to record all this because I wanted to give you a sense if you thought, man, I'll fix my own amp, and or you had a broke amp and you wanted to take it to a repair shop, and I know there's fewer and fewer places that repair amplifiers, and that is because that you can get them so cheap from China. A lot of them aren't worth repairing, you know. It's just not worth spending the money. And so we got a few FETs that you never know, might be okay. We'll look them over here in a second. I've got some FET legs. We'll put over here in the FET pile. Continue on. Oh, I have not hit this with the solder. Oh, and I was going to do these. So, yeah, that's what I'd initially worried about, is whether or not I'd drawn that circuit out. Like I said, I try to do a little bit of prep for these. Obviously, from the last video where the drive circuit for the power supply caught me off guard, and the fact that it's not 100% repaired yet. We still have to go through and fix the audio side of the subwoofer. So something in there's not right. And it is not letting the subwoofer drive, but it's not enough to blow a fuse or anything. So whatever it is, it's a loss of signal somewhere. We will see if we can trace that signal down. What I'll do is I'll actually probably I have identified which transistors are for the subwoofer, but I didn't go through and start kind of looking at the circuit, since it's a 5-channel amp. There's a lot of audio circuit there, so I kind of need a little bit of familiarity with it, little time on my own, just to find all the stuff so that I can point out how I did it and why and stuff, and You know, you think watching me desolder all this is boring. Oh man, that'd be just terrible, terrible boring. So, but I also want to show you some of this. I don't want to do all of it just magically. Take the amp comes apart magically, components go out, and I tell you, oh well, it had bad this or that. I want to show you what you see, and I want to show you what a tech would see if you were paying somebody to fix your amp, and give you a little bit of an idea of what he's got to sit there and go through bare minimum to fix your amplifier. You know, we're gonna hopefully fix this power supply, but you know, just like the last amp, that doesn't mean anything about these output transistors. They could be shot. Depending on, and I'm not super familiar with this JL, this A. But it could have you know, much beefier components in the output. Get that one dropped out of there, and get this other big one dropped out here. So beefy enough to handle just about anything, and it could be that the power supply is the weak link. That's pretty rare. Normally you blow an output and the protection, so it blows on big amps, it blows, and it causes a dead short to the power supply, too much current to the power supply, so fast that the protection circuits can't catch it, and so that ends up overheating and killing one power supply FET. And when the power supply FET goes down, normally there is no protection circuits for the power supply. That's what your fuse is there for, and that is why it's very important to use a fuse. Use the correct fuse. Don't be jamming some big fuse in there because you're tired of popping it. You know, if it says 40 amp fuse and you put it in there and you're popping a 40 amp fuse and you go, oh man, I put a 45 in there, which I know there's probably not a 45, but and it stops popping, that's great and all, but now you've just taken away the manufacturer's recommended protection. So we got 4 intact plus 2 more. We'll clean them up and see what happens. But we got a bit of a mess there. And we definitely got a mess here. So we've already got a heck of a mess on the workbench, and we haven't fixed nothing. And we've only taken out FETs. We haven't even taken out all the drive resistors that's going to be in there. Oh, let's take this to the trash. All the drive resistors. So let's put these FETs up over here. We got just terrible looking drive resistors. Let's see if I can get a pointing device. You know, that's a drive resistor. And it's just charred. Now, not all those are going to be bad necessarily. Probably the ones that went to blown FETs. Oh, I missed some legs there. I have to go back and try to get them. So let's go back here. Might be able to get them from top. Never know. Let's try. Yeah, there we go. Thought that went a little fast. Stinks like burnt transistor, burnt electronics. So now we've got that out, and you know, that cap's melted, that cap's melted. That one looks okay, and that one looks okay, maybe. Rubbing alcohol, and we're going to just start gently. We're going to get a little rubbing alcohol here, and we're going to clean up. I mean, the explosive nastiness flies everywhere, and so we're just going to start cleaning up as we go down through here, and looking to see what we can do. The reason why I started far enough back is because I'm wanting to push all the carbon to one area as we go. Try and get it out of here. But you can get so much damage to a board. That's just nasty. That it'll, especially on cheap Korean made, Chinese made stuff. Is that? Hang on just a second here. Well, I'm not calling it a smoking gun or nothing, but let's see. If we can get this thing to focus. There is a piece of copper wire right there that is left over that was hanging off into that that area. And it was mixed in with that. And so you never know. You got to be real careful with your speaker wire and your power wires. You know, you get frays off those. If they end up in the amp, and the amps are like a magnet to suck those things in. For some reason, they just are. It will find its way into parts and dead short them out and ruin your amplifier. So all we're doing here is removing some soot, trying to find out what is truly burned up, and it doesn't look like much. Some of these resistors are coming back where you can read them. That cap is toast. This big pull down resistor looks okay. That's pretty shot. Little bitty stainless steel bowls from Walmart. I think it's a 3-pack. Definitely worth the money of buying it to put your acetone or your mineral spirits in. Put a few squirts or a little dribble. We're just going to clean. I know, terribly exciting, isn't it? Great stuff to watch on the amp, but if you can see, let's see if I can center this up a little better. As I'm cleaning, some of these resistors you can read now, and so this is really an important step when you've got a blown amp. And this is part of why technicians are it's gonna cost so much for your amp to get repaired. He's got to go through and clean this mess up and just be able to try to get a, you know, some identification of what these parts are that are either A, covered in soot, or blown up. You know, that's so melted you can't see it. Now, thankfully, those four are all the same. But I'm going to end up taking all those out and sucking all those out. And so, you know, this has already been on for half an hour now. Off camera, going to clean on this sucker a whole lot more. Going to remove these four caps. Going to remove all of these drive resistors that go to each FET. Clean out all those holes. Going to remove all of the remaining drive transistors. Clean out those holes. Only thing that'll be left up here is these big resistors, and we'll test them, but they normally survive just fine. There is also a surface mount resistor here and here and here and here that we will check, and if they ain't perfect, we will replace those. But I'm going to clean all that stuff up off camera, suck out all these holes. I've bored you enough, but I kind of wanted you to get the gist of, man, it took us 30 minutes just to kind of talk through this, get all this stuff apart and out of here, and just start cleaning it up so we can see some stuff. And now we can see that these are brown, black, brown blue. I gotta turn my overhead light on to get a little more light and get this up a little closer. Man, when they get hot, they discolor, so it's really hard. So it looks like yellow, brown, black, 47 ohm, is that right? Yellow, brown, no, that can't be right. Yellow, brown, black. Let's look. So I got my cell phone. There's a little app called Electrodroid. That's the app. Oh, turn off the overhead light. That is the app, and it's got SMD resistor codes, color codes, anything else. So what did I say? Yellow, brown, black, 41 ohm. Does that seem right? I've never heard 41 ohm. I've only heard of 47. What's 7? Purple. Oh, I bet you that's a discolored purple. Let's put the old meter on there. Check one of these down here at the end that doesn't look fried. 46, 44, yeah. 46, that's 47, so that is. That's why cleaning it, you got to clean all of these, because you're going to have to look at multiple ones. Hopefully find ones that look somewhat intact, so that you can test a couple of them and know. So we got 47 ohm. So we got 1, 2, 3, 4, 5, 6, 7, 8, 16 of those I want to replace. You know, I want them to all look nice and uniform. I should have those. 47 ohm. Yeah, I've got a baggie of those. So anyway, like I said, we'll pull all that out. Then we'll rebuild one side probably next time on. I may rebuild one side off camera and then rebuild the other side with you on camera, so that then we can go ahead and do some testing. But actually, I take that back. I'll clean all this out. We will then I will do a short one where we fire it up and we'll figure out where the drive chip is here and look for the drive signals on where these transistors go. If that's all good, we'll slap back the caps in. We'll slap the drive transistors back in and the drive resistors before we put any FETs, and look for good drive signal on where the gates of the FETs are going to go. And I'll have done some tests on these, and we will then stick in, we will determine which ones are parallel. This is a great amp for me to show you the parallels. We're going to have 4 and 4 and 4 and 4, so it's a fantastic way to show. So we'll end up sticking a FET and a FET and a FET and a FET, and we should be able to power up both of these. Since they have one set of diodes, I don't know if they're hooked up this way for more voltage, or they're probably hooked parallel for more current. Technically, you can do it either way. I don't know. I'm not an amp designer. I'm a hobbyist, so it doesn't matter. We're going to be able to read coming out of the FETs, make sure we got good square waves there, and then we'll be able to read the voltage off the center legs of these diodes, and see if we got good rail voltage after that. We may have to take these diodes out if, when we put those 4 test ones in, if we pop a fuse. Remember, I run my power supply on a really small fuse, anywhere from 5 to 10 amps. 10 amps for really big, or a 10 amp one for really big ones, 5 amps for small. I like to normally try them at a 5, and we will probably put the 5 in for this, because not sure if these output FETs are any good, or if anything else was damaged. The only thing I'm sure of is that they did not check shorted, and I'll double check that while I've got it out of the case, and it's easier to get to. But that's what we're going to do. Look forward to that probably in a few days. As I sort through a few more of these amps. I've promised a bunch of different shots, and there's some people excited about seeing some stuff from the Rockford. And I got a Rockford with the Mesha, or whatever you want to call them, strip that everything's soldered down to. It's like another circuit board. All the backs of the FETs are, and those are real difficult for people to repair. And I'll show you how I do it with my hot air, what I would recommend, and one little nifty trick that you can do if you are around Black Friday time. It makes it cheap. Otherwise, you might be able to go to the thrift store. But it's a pretty slick way to take care of that, because other amps use other brands of amps use things soldered to the back of the FETs, and it's kind of a handy way to do it. So, all right, I appreciate you watching. If you're interested in seeing this big old monster amp get fixed, and this power supply, and hopefully if that's it, we go. But as we've seen on the last amp, not necessarily the case, but we do one thing at a time. You can't test any of this stuff without having a working power supply. So if this helps you out a little bit, piques your interest, subscribe, comment. Man, comments. I like the comments. I just got a new person commenting. That was fantastic. I replied to that. And you know, and give me a thumbs up or something like that. And tell your friends, tell your enemies, tell your grandma. You know, getting a bunch of people to look at this and at least understand it. Keeping this stuff out of the landfill. Repairing your own stuff. Self-sufficiency. I'm big on right to repair and everything else, so having access to parts and schematics is important to me. So, like I said, thanks a bunch for watching, and I'll see you in the next video, man.